Example 33. Determine the specific energy if the depth of flow in a parabolic channel is 1.2 meters and the discharge is 4.5 cubic meters per second. The Froude number at that depth and the critical depth at of parabolic section. Then, if a hydraulic jump can occur, what will be the depth after the jump? The cross-sectional dimensions of the channel are height 2.4 meters and width across the top is 1.8 meters. Assume uniform flow. So this is the section. So we must express the depth of flow in general in terms of the base width, or we can solve for B if for number 1, 1.2 depth. So first, specific energy is velocity head plus depth. Let's compute for the area to compute for the velocity. By 2/3 of B times depth, and depth is 1.2 for number 1. By squared property of parabola, 1.2 as to B square equals 2.4 as to 1.8 square. So the top width is 1.273 of the water surface. So area therefore is 2/3 of 1.273 times 1.2. So 1.018 square meter. Velocity therefore is Q 4.5 over area 1.018. So the mean velocity of flow at that section is 4.42 meters per second. Let's call that section 1. So specific energy 4.42 square over 19.62 plus 1.2. So we have calculated the specific energy 2.196. The second question, the Froude number at that depth. So Froude number 1 is V1 over square root of G hydraulic depth 1, because this is non-rectangular. So hydraulic depth is area over top width only. So FR1 equals 4.42 over 9.81, area is 1.08, and the top width is 1.273. So Froude number is 1.578. This is greater than 1, therefore this depth at 1.2 is in the lower stage. So it is supercritical, the flow is supercritical, so hydraulic jump can occur. But before that, the critical depth of parabolic section. The formula for critical depth is capital Q square over G equals area critical cube over top width. Now, the area is 2/3 of B times critical depth, where B must be a function of the critical depth also. So by squared property, make this critical depth as to B square equals 2.4 as to 1.8 square. So the top width is 1.162 square root of critical depth. Then that's it. The area therefore critical is 2/3 of 1.162 square root of critical depth times critical depth. So simplifying, area critical is 0.7747 critical depth to the 1.5. So substitute in this formula, 4.5 square over 9.81 equals quantity 0.7747 critical depth to the 1.5 cube over 1.162 square root of critical depth. Simplifying further, the right side is critical depth to the fourth. 5.159 equals critical depth to the fourth. So critical depth can now be computed, 1.507 meters. So it is really greater than 1.2 because this is in the subcritical stage. Then the depth after the jump. So the formula general is F2. By the way, before we proceed, the location of the centroid of this area is 2/5 of depth. So if this is depth 2 after the jump, then that's 2/5 of depth 2 or 0.4 of depth 2. So F2, hydrostatic force F2 at section 2 minus hydrostatic force at section 1 before the jump equals Q rho quantity V1 minus V2. So area 2 is 0.7747 depth 2 to the 1.5. We just pattern it after critical area, because if we denote this by depth 2, we arrive at the same relationship for area 2. Then 9.81 times barred h2 zero point 0.4 of d sub 2 area 2, that's f2 minus 9.81 barred h of depth 1, which is zero point 0.4 of 1.2 section 1 1.2 meter, area 1 is 1.018, equals discharge 4.5 times density 1000 over 1000. The left side is in kilonewton, so we make the right side kilonewtons also. V1 is 4.42 here, this one. Then V2 is discharge over area 2. Discharge 4.5 over area 2, that's V sub 2. Simplifying, this becomes 3.04 D2 to the 2.5, then 4.5, don't mind 1000 over 1000. 4.5 times 4.5 over 0.7747 D sub 2 to the 1.5 to the left is positive 26.14 over D sub 2 to the 1.5. Then negative 9.81 times zero point 0.4 times 1.2 times 1.018 minus 4.5 times 4.42, that's negative 24.68, equals 0. So solving for this equation using the high-tech calculator or by trial and error, we can now compute depth after the jump of 1.863 meters. So that's it for this problem.